discussing the applications of vectors in geometry, and as I've already told you, it is a good concept, but yes, it just demands a good amount of practice because it contains a huge amount of formulae. Like we shall discuss that if you have a line parallel to a vector B passing through a vector A, then it will be of the form R equal to A plus TB, where T is a constant. So we shall discuss various formulae followed by the questions based on the concept. So let's begin.
Okay, so now we have the applications of vectors in geometry. This is again an interesting topic, but yes, it involves good amount of formulae, so you'll have to practice a very good number of questions, and memorizing formulae can be a tedious task. So first of all, we have is vector equation of a straight line passing through a point A and parallel to B is R vector equal to A plus TB, where T is an arbitrary constant. So if you have to find out the vector equation of a straight line passing through a vector A and parallel to some vector B, then that would be equal to R equal to A plus TB. This is in fact quite obvious also, A plus scalar multiple scalar times vector B. Similarly, vector equation of a straight line passing through 2 points A and B is R equal to A plus T B minus A. This is important. Vector equation of a plane passing through a point A and parallel to two given vectors B and C is R equal to A plus SB plus TC, where T and S are arbitrary constants, or RBC is equal to ABC. Vector equation of a plane passing through the point A and perpendicular to n is R dot n is equal to A dot n, and the perpendicular distance of the plane from origin is A dot n by magnitude of the vector A. Next property says perpendicular distance of a point Px from a line passing through A and parallel to B is given by this formula, that is Pm is magnitude of R minus A cross B by magnitude of B, which can also be expressed as this. The perpendicular distance of a point PR from a plane passing through A and parallel to B and C is given by Pm is equal to R minus A dot B cross C by magnitude of B cross C. The perpendicular distance of a point PR from a plane passing through the points A, B and C is given by Pm is R minus A dot product into B cross C plus C cross A plus A cross B divided by modulus or magnitude of B cross C plus C cross A plus A cross B. Okay, so now we have certain examples based on these. The first one says a non-zero vector A is parallel to the line of intersection of the plane determined by the vectors I plus j and the plane determined by the vectors I minus j, I plus k. Find the angle between A and the vector I minus 2j plus 2k. Okay, so how do you proceed in this question? It is saying, first of all, we'll take the equations of the planes R equal to Pi plus Q times I plus J minus I. This vector minus this vector. So Q times I plus J minus I. So this becomes Pi plus Qj. Right? And then we have T times, second vector is I minus J. So I minus J plus suppose S times I plus K minus I plus J. Again second times minus, minus first. So we have S times I plus K minus I plus J. T times I minus J plus S times I plus K minus I plus J, which is equal to T times, this is T, Ti plus S minus Tj plus Sk. We have just compiled the coefficients of I vector. I is S plus okay, this here I will get cancelled. So we have t times I plus, for j I have s, here I have minus t, so s minus t times j plus sk. Now for the line of intersection, next I'll write for their line of intersection. For the line of intersection, what we'll have is that s should be equal to 0, then s minus t is equal to q. From here, s minus t should be equal to q, s should be equal to 0, and t is equal to p. So this implies minus t is q, this is s minus t. So minus t is q, and therefore I have my r vector is t times I minus j, right? Moreover, since further it is given in the question, you can see A is parallel to the line of intersection of the plane determined by this and this, find the angle between A and vector this. Okay, so since A is parallel to this vector, A is parallel to R, therefore A is parallel to R, therefore we can assume A to be lambda times I minus j. Since my R is t times I minus j, so and A is given to be parallel to R, therefore A can be assumed to be lambda times I minus j. Now we are required to find out the angle, so we are assuming let theta be the angle between A and the vector given to us was I minus 2j plus 2k. So I minus 2j plus 2k. Let theta be the angle between A and I minus 2j plus 2k. Then A into I minus 2j plus 2k is equal to, this we have already discussed again these formulae. So this will imply, now again A is lambda times I minus j. So in fact you can just substitute the values. Lambda times I minus j into I minus 2j plus 2k would be equal to, now modulus of A, the magnitude of A would be equal to lambda times under root of 1 plus 1 into magnitude of this vector would be equal to 1 plus 4 into cos theta, right? So this implies lambda times, now I'll take out this dot product, so this is A times this, A into this, so this will give me lambda times 1 plus 2, because I dot I would be 1 and then we'll get zeros, so I have 1 plus 2 is equal to lambda times under root 2 under root 9 cos theta. This means 3 lambda is root 2 lambda 3 cos theta. So 3 in fact lambda also gets cancelled, so I have cos theta is 1 by root 2, and therefore theta is 45 degrees. And since we were required to find out the angle between A and R, between A and the given vector, and we have obtained the angle as 45 degrees. The next question that we have is, find the vector equation of a line passing through a point with position vector 2i minus j plus k and parallel to the line joining the points with position vectors minus I plus 4j plus k and I plus 2j plus 2k. Also find the Cartesian equivalence of this equation. Okay. So let A vector is equal to 2i minus j plus k. I am assuming this to be A vector. Then I assume this to be B vector minus I plus 4j plus k, and C vector is I plus 2j plus 2k, right? So my A vector is this, B is this, and C is this. Now equation of the line would be, the equation of the line would be R equal to A plus T times C minus B, right? So this would be equal to, my A is 2I minus J plus K plus T times I plus 2J plus 2K minus minus will become plus minus 4J minus K. This is what we get. I've just substituted the values of A, B and C. So this gives me, in fact now I'll be compiling the coefficients of I, J and I, J and K. So what do we get? Now just simplify this. So I get 2I minus J plus K. In fact we won't have to compile the terms of I, J and K. Then I get 2I minus J plus K plus T times, I have 2I minus of 2J, we have 2J minus 4J, so it becomes minus of 2J, and 2K minus K is K, so we have plus K. This is what we get. Then R is equal to, now let us suppose let R is equal to xi plus yj plus zk. Then R is equal to xi plus yj plus zk. Then what we'll do is xi plus yj plus zk would be equal to, we had obtained 2I minus j plus k. Let's see what we had got. 2I minus j plus k plus t times 2I minus 2j plus k. So 2I minus j plus k plus t times 2I minus 2j plus k, right? 2I minus 2j plus k. So now what we'll do is we'll try to find out the coefficient. In fact, we'll be equating the coefficients of I, J and k. So we get, this can be written as, in fact, 2 plus 2t I plus minus 1 minus 2t j plus 1 plus t k. This is what we have obtained. So this means x is 2 plus 2t, y is minus 1 minus 2t, and z is 1 plus t. This is what we have obtained, the values of x, y and z. And so this means x minus 2 will be equal to 2t. Then y plus 1 would be equal to minus of 2t. Right, we have taken 1 on this side, so y plus 1 becomes minus 2t, and z minus 1 is t. Thus, what does this yield? That x minus 2 is 2t, y plus 1 is minus 2t, and z minus 1 is t. So finally what we get is x minus 2 by 2 would be equal to y plus 1 by minus 2. T would be equal to x minus 2 by 2, and from here I get y plus 1 by minus 2, and from here I get z minus 1 by 1, which is equal to t. This is how we have obtained the values of t, and I have equated this term is equal to this term is equal to this term, and which is the required equation of the line in Cartesian form, which is the required equation of line in Cartesian form. So see, this question was also quite simple, but yes, until and unless you know these formulae, you cannot solve out these questions which are based on applications of vectors. So you'll have to practice a very good number of questions. In fact, in the next session we'll also be discussing some of the IIT-JEE questions of previous years from this portion, that is vectors. So just to practice a very good number of questions, and the formula should be on your fingertips. So I hope you must
must have understood the applications of vectors in geometry. I would again like to repeat that it is a tedious concept because it involves a good amount of formulae. So just practice a good number of questions on it and you will be through. Now, finally, in the next session, we'll be discussing some of the IIT-JEE questions based on vectors. This will help you to get to know what kind of questions exactly can you expect in your exams from the chapter vectors. So just stay tuned.